Hello everyone, welcome back. This is the usual stream for writing a writing a programming language in Rust. My name's Sean. Let's get into it. So what I was working on last day was that yesterday potentially? I think it was yesterday. Was the implementation of this feature catching as a boolean, which is a question mark prefix for expressions. The idea being that if an exception, so in this language, all errors are exceptions. You don't really return error values. They're returned as exceptions because this is intended to be more of a scripting language. And so most of the error handling is going to be more default, and you will maybe catch some error conditions, I guess, in general. So in general, you're just going to let errors bubble up and exceptions bubble up to the top level and just crash the program. But you're going to be able to catch them if you feel like it. And the slight enhancement that we have here is that if you have a single question mark, instead of catching the error object, you will catch, basically it will coerce it into a boolean, so to speak. And so if the boolean is true, then everything was okay and you can continue processing as normal. Otherwise, you can handle the fact that there was an exception. You won't have details of the exception, but you'll know that an exception occurred and you can do some different processing if you want to. Now, what we had been working on was this idea of when an error occurs in general from the evaluator, then we have this error type defined for the language, and most of these errors are going to be not runtime errors as such. They're going to be more like language or syntax or semantic errors, where it's 9.99 times out of 10 the issue is going to be a developer error where the language is just not used in the right way. So maybe you tried to assign to an integer or something that just the language doesn't allow, but where the rules are defined in logic rather than the parser and lexer. And so when we have that kind of a scenario, we want to get down to the kind of root error, which is still of this error type, because most errors in this type as well, most error variants rather, are going to be of these failed types. So it's recursively giving you almost like a stack trace down to the element that actually failed. And now that I think of it, would a lot of this logic make more sense to just encode as a stack trace using Snafu, because it does support that? Is there a reason why that wouldn't be possible? To be honest, I'm going to leave it for the moment. I'm not going to, but now that I've thought about it, that is potentially something I'm going to want to look at more later. Not really sure why I don't have a display defined for this. I guess because it's a failed. Anyway, back to the issue at hand. Basically what we want to do in most cases where we are wrapping a nested error is we want to recursively unwrap until we get down to the root error. And if the root error is a runtime error, then we're going to allow it to be coerced into a boolean. It's going to be essentially a handleable error. Otherwise, it's going to be one of these kind of language errors. And I'd been spending a lot of time figuring out how to and getting a lot of help from ChatGPT as well, figuring out how to unwind the stack in kind of a programmatic way. And so what I was able to find was that Snafu, if we import the error type, it extends the error type with a source field, and that will return the source property from the variant. And so we can keep going down while the current error has a source, up until the point that so once we have an error, now source doesn't return our error type, it returns a dynamic error value, i.e. An implementation of a trait. So this is not of our error type, so we can't actually check if it's one of our local variants. So what we instead need to do is downcast it back to box error. And so all of these failed variants, their source is a box error. And so if we're able to downcast to a box error, we know it's still of our error type, and we keep drilling down into and unwrapping in a loop until we get to an error that we can't do that on, and then we return that error. So it's either we've gotten to an error that doesn't have a source, in which case it's the root, or we get down to an error that where the source is of a different type. So for example, if we have, let's see, so a bunch of those don't have sources, but some do. So a typical one is an integer, a string conversion. So if we have a from UTF-8 error, that's of a different type to our error type. And so it's going to cause us to exit the loop. So just adding a bit of documentation here, we're going to say root error returns or recursively unwraps, or rather follows the source chain of error to find and returns the deepest error instance that was found. And so with that implementation finally present, we now have a root error that we can check against the runtime variant, and that's going to be the type that we're going to allow catching on. So I've compiled this already and run it on the tests, and so it has us passing one of the tests which had previously failed. I actually won't be able to find it in that list, but it was to do with, let me see. So if we go to catch test, I think, yeah, the property not found tests. So both in the case of using the kind of dynamic lookup format or using the shorthand. So let's go ahead and convert some of these other error types into runtime errors. So let's see, we have equal type mismatch. Yeah, and that's this one. So we'll do a search for that variant in our mod implementation. And so that's going to be now runtime error. And it's just going to have a message, and the message is going to be basically our display implementation just with the parameters put in directly. So we have HS type and binary op symbol. So we'll probably need to import that from error. And that will need to be made public as well. Yeah, and that's another one of our errors now passing. So let's take a look. We also have string and list bound issues that we're going to add some more flexibility around. And I think that's the only instance of that variant, and we're going to have the same kind of setup down here as well. And once we're adding the support for actually capturing or catching different error types, we'll be adding more distinction. At the moment, we just have all the runtime errors are basically just defined by their message, but we'll be adding more structure to this as we add more error handling support. So let's see. That's probably all the test passing. So we also have that same variant in bind on line 104. And so the last one that we're going to add for support for is going to be overflow. Did we handle all the prop not found situations? almost. Yeah, so we handled all of them in mod, but not everywhere in general. So let's go and copy the code that we used in mod. So that's going to be one of these runtime instances. And this will do fine. Yeah, and I guess that's the last one that I've marked for the moment anyway. So that's going to be int overflow. So let's see where that comes up. It's not in bind, but it is in mod. So let's copy another one of our runtime instances. And copy over our message. And that's basically going to be it. Oh yeah, and that is the short circuit evaluation situation, which we will be tackling shortly, potentially right after this feature has been implemented. And so we're going to want to bump the version. This is going to be a new feature, so we're going to want some documentation for that as well. But before we recompile all that, let's see what linting errors we have. So in bind, we can say index n there. 616 to string applied to a type that implements display. Next, we're moving on to mod. Now that one I don't want to change because it is going to overflow the line. So we'll go something like this. Allow Clippy on inlined format args. And we're possibly going to want to do the same up here as well. And 614. Yeah, same situation. Cool, 847. Same thing. Although for this one, actually, I can inline it. Is that allowed? Does that give us the right? Okay, I need underscores there. And before I forget, we need some docs. So let's see, standard out. We'll have our features file as always. And let's go ahead and open some of the tests that we've already written. Cool, so now we're going to want to dive into the docs. This is going to be going under control flow. So this is nearly a whole other thing. Now, whether to add the description here or to add it elsewhere, I guess I can just add it here and then relocate it as time goes on. But we'll nearly want a philosophy section. So one important expectation here is that most scripts aren't going to be tested. So if you're going to be having unit tests and things like that, you're probably going to be writing this in a more, not necessarily more robust language, but a language with more features for helping confirm correctness. So types and things like that. So if you're using this language, the expectation is that it's going to be untested. And in those kind of situations, you're really only programming the happy path because you're not testing all the other situations. And so if you ever veer off the happy path, then you just want to fail fast because you probably haven't tested most of the other situations or scenarios that could come up. Are going to be So with this in mind, because Ash programs focus on the happy path, we also expect that we won't often actually handle errors, and especially in a comprehensive way. So we'll probably make a little bit of assumption when we're doing error handling. So rather than a block-based exception catching and turns the operation and returns so we'll take our sample code here. Well, I don't necessarily want to say if no exception occurred, because an exception could be occurring at a more nested or a deeper level and then caught within it. So and that is basically it, I think. I mean, it's not too, I guess, deep or fleshed out so far in terms of documentation, but I think it's sufficient. No, I don't want that one to be kept, and same with that. That can be removed. No, that one won't be committed just yet. But I will rename that error because it says cannot catch runtime error, but those are exactly the errors that can be caught. And maybe it's worth adding a little note on that. That's a good example of this. actually, I'm referring to errors a lot, but while the approach is error handling, the actual mechanism, the type of value that's being propagated is an exception. Now, having said that, maybe that's something that will change in time, because I know, for example, the likes of Python has a distinction of, for example, syntax errors, and I think you can catch those. Well, actually, I'm going to take a look. Let's see. So we've built in exceptions, and they're all derived from base exception. Yeah, and I guess you can catch those. I mean, in a way, that's possibly useful in a situation where for example, an import is doing mostly what you want it to do, but then there's some exceptional situation where it is crashing and not doing the thing that you want to do. And in fact, I think the Python, whoops, what's after happening there? The Python exception actually describes that. Yeah, so like if it occurs in someone else's code, that's kind of its own thing. And yeah, maybe, I guess there are going to be scenarios where we want to just allow the program to keep processing. I guess it's something that maybe you can't handle as such, so you won't be able to catch it as boolean or catch it as an error, but you're going to be allowed to just ignore it. And maybe that can be the situation if the entire statement is just prefixed with a question mark. So that's going to denote that you can keep processing even if there was an error, or even if there was a language error. And so that will allow you to keep processing even though there was something that fundamentally was, not supported by the language. But for the moment, I'm going to say that that's not allowed, but it's going to be something that will be added in a future commit. Find is obviously going into the Git directory in that case. It'd be nice to be able to skip that. Let's see. Oh, keep forgetting to undo the browser. I really need to do like a plugin or something for that. Anyway, for the moment, we'll just focus on this. So we'll do our git push. And that is finally support for errors added to our language. And so what I was thinking of doing next was going to be looking at short circuit conditionals. But I think I'm going to leave it here for today. I think that was a nice amount of work accomplished. So yeah, I'm going to leave it at that for today. I think, wow, I'm tripping over my words a lot today. So yeah, as always, thanks to everyone who's checking this out. Please feel free to interact, to comment, like, subscribe, whatever the platform that you're checking this out on supports. And yeah, I'll see you again. Take care. I think I've deleted my scene for going offline. I'm not sure what's going on there. Okay, I guess I'm just going to, yeah, I don't really have a scene to go to go offline, so I guess I'm just going to stop streaming there. Yeah, okay, let's go for it.